one letter A. I'm not sure how to draw that or how the vectors that I need would look like on that, so I can't get very far with
1A
it.
you're talking about?
Yeah.
So you have a line. So you want to find a plane that contains this line and parallel to this plane. So let me draw this line, this plane first. So this plane is what? 5x plus 2y plus z equals 1. Okay. Now you want to find a line, a plane which is parallel to this. That means the plane you want to find, that's here. Right? They're parallel. And this line also lies in this line lies in this plane. Okay. So what do you need to find a plane, equation of a plane? You need a normal vector, you need a point, right? So first of all, I'll ask you, what is the normal vector to this plane?
Is it 5, 2, 1?
Yes, the coefficient of x, y, z. So what is the normal vector of this red plane then, which is parallel to this?
It would be the same thing, wouldn't it?
Yes, exactly. That's the catch, because they're parallel. Now what else do you need? You know the normal vector. What else do you need?
I need a point on the plane that
Yeah.
I'm looking for.
Right. So you already know this line is on the plane, right? That means any point on the line is also on the plane.
Okay.
So if you plug, for example, any value of t, you'll get a point. If you plug t equals 0, for example, what do you get? 1 to 4. So 1 to 4 is a point on the line, hence on the plane.
All right.
You should be able to do the rest.
Thank you.
Other questions? It doesn't have to be just planes. You can ask any chapter 12 questions.
I have a question real quick.
Mm-hmm.
Can you do, it's on problem, or are we only doing problem set 5, or can we do other problem sets and go over them?
Any chapter 12 question.
Okay, it's on problem set 4, question 2.
Then I have to open. Problem set 4, which one?
Number 2.
Find a vector equation, parametric equation, symmetric equation of the line through this point and perpendicular to both. So to draw a line, to get an equation of a line, what do you need? A point and direction vector, right?
Right.
So what will be the direction vector? So you want to find the line which is perpendicular to both. That means what? This line is perpendicular to both means
It intersects.
no, not intersects. So think about the like three-dimensional case. If you have um, if you have two lines on xy plane, right? So what would be a line perpendicular to both? It would be a parallel to the plane that contains these two lines, right? And how do you get that? You get that by the cross product of these two vectors, right? So the direction vector, would be the cross product of these two vectors. And then find ABC. Now you have a point. So you have a direction vector and you have a point. So then what is the general form? General form is, if you do vector equation, then general form is R dot product with R0 T times ABC, right? And this case, this is 210. So 210 T times or whatever ABC you found from here. This is the vector equation. Okay, so if you want to do the scalar equation, remember this R is what? This is a position vector of a general point on the line. So this is just XYZ. So now if you compare both sides, then X is what? X is 2 plus TA, Y is 1 plus TB, Z is 0 plus TC. This is your symmetric, scalar equation or parametric equation. And then if you solve for T for each and equate them, that's called symmetric equation. If you do that, then X minus 2 over A is T, Y minus 1 over B is T, and Z minus 0 over C is also T. So if you equate them, then you get a symmetric equation. Is that good? Tommy?
Yeah, thank you.
Okay. Feel free to ask questions.
I had a question about number 6 on problem set 3. If we could just like go over how to do that one, because I tried it, but I definitely was not doing anything right.
Which problem?
Number 6. Is it?
So true false one. That's one, right?
Yeah,
This one?
yeah.
Okay. So look at this. What is this saying? A dot B equals A dot C. So you can, if you subtract that to the left hand side, that will give you 0, right? And if you do
Yes.
algebra, take A as a common factor, dot B minus C equals 0. Right? So what does this mean? That means A is perpendicular to B minus C. B minus C does not have to be 0. Right? If B equals C, obviously this is true. But still it, you know, we can get a quick example. Even we can do two-dimensional example. So you can do 1, 2, and this is, let's say, 2, -1. So obviously this is 0, right? But
Yeah.
these can be come from B minus C as, let's say, 2, 0 minus 0, 1. You see, this is B, this is C. They are not 0, they are not equal. But B minus C is perpendicular to A, right?
Yeah.
Same thing is true here. You know, if you do this part, A cross B minus C is 0 vector. That means what? This is parallel to B minus C. Doesn't mean that B and B minus C is 0 vector. But if you have both, that's the part C. What does that mean? A is, if you have this, that means what? B minus C is parallel to A, and if you have this, that means B minus C also perpendicular to A. So A is not a 0 vector, right?
Right.
The B minus is perpendicular and parallel, so only way it can happen that this is a 0 vector,
Okay, that makes sense.
which means B equals C.
Gotcha. Thank you.
Mm-hmm.